Set up an integral to find the volume of the solid formed by rotating the region enclosed by the curves y equals the square root of x and y equals x squared about the line y equals 2. Ooh, all right. So we got one guy, we've got another guy, and we're rotating it around something up here. I don't even know if that line is accurate. I don't even know if it's accurate at all. But this is what I do know, is this is the washer's method, all right, surrounded or spun around a different axis. So this is taking all the horrible stuff we learned in the last like 4 sections and putting it all together. So the washer's method using this way is going to be like the regular washer's method. Okay, and it's washer's method because of that space in between. The regular washer's method is so the integral from a to b, don't forget your pi out front. Okay, now what we're going to do is we're going to take a minus f of x. Now if you're wondering what a is the line you're spinning it around. So a minus f of x squared minus the same a minus g of x squared dx. All right, so I'm going to label the fact that the upper guy seems to be x squared. So you would be my, or no, the upper guy, I take it back, seems to be the square root of x. So you would be my f of x. You would be my g of x. So setting this up is I need my limits. So I find my limits by setting these two equal to each other. So before we even set things up, let's make sure that I know the limits are 0 and 1, but what if this wasn't multiple choice and you actually had to figure this out? All right, set these guys equal to each other. The limits are going to be the square root of x equals x squared. Why don't we square both sides, right? So that we get x equals x to the fourth. Subtract x from both sides to get x to the fourth minus x equals 0. Factor out an x to get x to the third minus 1 equals 0. And then you can see that your limits are going to be 0 and 1. So putting all this together, pi 0 to 1, parentheses, parentheses, a is going to be my 2. So 2 minus f of x is going to be the square root of x. So the square root of x squared minus 2 minus g of x, which is x squared, squared, close it, dx. And the one that seems to match that is C. Oh, I hate it. I hate it. Wait till the next one where we actually do the problem. Find the volume of the solid formed by rotating the region enclosed by the curves y equals x, x equals 0, and y equals 3 about the line y equals 4. This is using the washer method around a different axis. The equation for that is pi times the integral from a to b of whatever line you're rotating it about minus the upper equation, close that, square that, minus whatever line you're rotating it about, minus the lower equation, close it, square it, dx it. Okay? So, if I were to graph this, okay, y equals 3 lives right there, y equals x lives right here, okay, and we're spinning it around y equals 4. So what's going to be created is this weird like triangular looking thing. So basically you have that spun around, right? And you have this weird triangular looking object that's spun completely around. Okay, this would be like half of it. If I were to cut it in half, that's what it would look like. Okay, so yes, this is the washer's method. Now, according to this picture that I have, okay, this is my enclosed region and I'm spinning it around 4. My upper equation is going to be the 3, so you would be my f of x. My lower equation is going to be my x, so you would be g of x, right? I'm shutting you off at 0. You guys intersect at 3, so those are going to be my limits, so that's my a and that's my b. And I'm spinning it around y equals 4, which is going to be that a in there. Probably a poor choice by me using a twice, but that's all right. God will forgive me. So the integral that I can set up is going to be pi from 0 to 3 of 4 minus 3 squared minus 4 minus x squared dx. So pi from 0 to 3 of, thank you Jesus, 1 squared, I can handle that, minus perfect square trinomial is going to make that look like 16 minus 8x plus x squared dx. Distribute that negative. So pi 0 to 3, 1 minus 16 plus 8x minus x squared dx. Pi integral from 0 to 3, combine like terms, negative 15 plus 8x minus x squared dx. I haven't even integrated yet. That's the fun part about this problem. But here I go. Now I can integrate. Pi is still living out there. The integral of negative 15 is negative 15x plus that'll be 1/2, so 4x squared. And that'll just be minus regular 1/3 x cubed with limits at 0 and 3. Let's plug in 3. Pi times negative 15 times 3 plus 4 times 3 squared minus 1/3 times 3 cubed. If I plug in 0, it would be me plugging in 0 and getting 0 plus 0 minus 0 times pi, which is 0, so you get 0. Pi still lives on the outside. Negative 15 times 3 is negative 45. 3 squared is 9. 9 times 4 is 36. 3 cubed is 27 divided by negative 3 is negative 9. All of that becomes negative 18 pi. So that's what this means is I chose the wrong f of x and the wrong g of x. No big deal. The quick fix is just make it positive. And you get 18 pi. Yum, yum. 18 pi sounds like a good Thanksgiving to me. Thanks for watching. Please send help. The last problem of AP Calculus. Are you ready? The area bounded by the graphs of y equals negative 2x plus 6, y equals x, and x equals 0 is rotated around the line y equals negative 1. Use the washer method to write an integral and find the volume. So it's telling us what to do. We are going to actually use that washer method, so I'm just going to trust you. But here's the thing. I'm spinning it around y equals 1. So the equation that I like to use for the washer method is I have pi living out here. I have my integral from a to b. Okay, and I'm going to set up a, which is going to be the equation that I use, minus f of x, which is going to be my upper equation, squared minus a minus, again, the same a here, minus g of x, close it, square it, close it, dx it. Okay, so I'm going to allow u to be my f of x, because why not? I'm going to allow u to be my g of x, because why not? And I'm going to let u be my a. What I don't have are my limits of integration, so let's find my limits of integration by doing these two guys set equal to each other. So negative 2x plus 6 equals x. Add 2x to both sides, add 2x to both sides. 6 equals 3x means that I have divide by 3, x equals 2, and I'm already told that x equals 0. All right, so let's set this up. I got pi times the integral from 0 to 2. I have a, which is negative 1, so negative 1 minus negative 2x plus 6. And then we're going to square that. So I'll probably need another set of parentheses there. And move that parentheses out because it looks sloppy. Much better. Minus -1 minus x squared. Let's scooch u back in. Let's dx u. So that's going to end up being pi times the integral from 0 to 2 of, let's kill two birds with one stone to make life easy. That becomes negative, so that's 2x. U would become -6. Okay, so -6 minus 1 is -7. So that guy squared. I did it again with the parentheses. What's wrong with me today? Minus, why don't I perfect square trinomial that right now, so you get 1 plus 2x plus x squared. Okay? And then close that, dx that. Why don't we perfect square trinomial that, and you get 4x squared minus 28x plus 49 minus, while we're at it, why don't we distribute the negative here? 1 minus 2x minus x squared dx. So we could still do a lot of combining before we even integrate. So 0 to 2 is still there. Pi is still there. Can't forget that. 4x squared minus x squared is 3x squared. Negative 28x minus 2x is negative 30x. And then 49 minus 1 is 48. Still haven't integrated yet, until now. So you become pi times x cubed, perfect, minus 15x squared plus 48x. Limits are 0 and 2. Pi times 2 cubed minus 15 times 2 squared plus 48 times 2 minus, plug in 0, you get 0. Pi times, you become 8, you become minus 60, you become plus 96, and when all is said and done, 44 pi. If you stuck through it with me, thank you for watching. I love you guys. You're the best. Good luck on your AP exam and in life. And yeah, thanks. Love ya.